Hello student. So welcome to my channel. Today we will start unit number 1, projection of line. In this we are going to see uh, questions of oblique line, projection of oblique line. So here in this given data is line AB has its endpoint A 16 mm above HP, 25 mm in front of VP. So I will write given data here. Given data, point A is 16 mm above, 16 mm above. So in this question, given data is point A is 16 mm above XY line, above HP. So above HP, so we will draw in projection line. We will draw point A above XY line in front of VP. So point A is up in front of VP by 25 mm. So we will draw it below XY by 25 mm. Then plan length is given. The length of line in the plan means top view. So plan length is given 60 mm. Elevation length is given 65 mm, and distance between two projectors is equal to 45 mm is given. Now we have to find true length, then inclination of line with HP, that is theta, and inclination of line with VP, that is phi. Okay. So first we will draw a line XY, that is horizontal line of approximately there is no need to take distance, just draw line XY, mark it as XY, then by with the help of 2H pencil, take, if point A, the location of start point, that is point A, is given, then draw a faint line perpendicular to XY. Then on this line, take a point above XY line by 16 mm. So take 1.6 centimeter above XY line and take 2.5 mm below XY line. 2.5 mm below XY line. So these are the 2 points. So above XY line, this area is for front view. This area is for front view as per first angle method, and below XY line, this area is for top view. So we will mark a point of front view as small letter and dash. Okay, so I will mark point A in front view as small dash, and this area is for top view area. So this area is for top view area, and in top view area we will mark point with small letter without dash. Now these are 2 points. Now in question it is given that the true length is not given. The plan length means top view of a line, top view of a oblique line is given 60 mm. And so first, as per concept from theory of projection, we will draw a baseline originating from this start point parallel to XY. So this is a baseline. Now the plan length is 60 mm. So plan length is 60 mm. So plan length means top view, right? So take 60 mm on this line, on this baseline in top view, and draw an arc of 60 mm. So the angle of line length is not known till now, right? So just draw arc. So it means that from this point to point on this arc there should be a line length. Now in question, a perpendicular distance between two projectors is given. It is equal to 45 mm. So elevation length is given 65 mm. So we will take 65 mm on this baseline and draw arc of 65 mm. The distance between n projectors is equal to 45 mm. So the first projector line is a line starting from these two start point, and the second projector is a line of end point. So on 45 mm, so this distance is 45 mm. This is the distance between two projector lines. So at this point there should be a second projector. So this should be a projector 2, and this is a projector 1. Now projector means a line passing from end point of elevation length and end point of plan length, and this arc is the arc of elevation length arc, right? So this intersecting point, it means this point is a end point of elevation length. This length is of 65 mm, right? And from this intersecting point, if we join this point A, so this line will be the planned length with inclination. Okay, so after we know the end point of planned length and end point of elevation length, we can draw a locus line parallel to xy. Parallel to xy. So this is a locus line in front view, and this is locus line in top view. Now in on locus line there should be a end point of true length. So the true length means actual length, right? Elevation length means the front view of a length, and plan length means top view of a length. So elevation length, this is the elevation length, this is the front view, this is the projection of projection in the front view area, right? So if we take projection of this point in the opposite area, that is top view area, up to locus line, then we will get the end point of true length. And if we take projection of plan length up to this area, up to locus line, then we will get the true length in front view. So this length is true length in front view, and this length is true length in top view. Now we will measure the angles. So after measuring the length, true length is equal to 78 mm, theta is equal to 37.5 degree, and phi is equal to 32 degree. So this is our answer, and this is naming. For naming we will use dash, small letter with dash for front view, The elevation length is our actual elevation length and plan length is our actual answer. So we will mark this point as A dash and B dash, and the plan length as small a and b, AB. Then true length as A dash B1 dash. The projection of B1 dash on the baseline in opposite area is B1, and projection of B2 on baseline of opposite area is B2 dash. Okay, so all letters here in front view are with dash, and all letters in top view are without dash. Okay, so this is how our presentation should look. This is a diagram with dimensions.